Hello friends, in the last video I have explained to you how to calculate the lateral load carrying capacity of a pipe using IS code method. IS 2911 can be used for calculating the lateral load carrying capacity of a pipe. Let us take one example. Let's say this is the pipe made of M30 concrete and it is embedded into a ground which is over consolidated clay. The properties is given, the modulus of subgrade reaction is given over here as 15,000 kilonewton per cubic meter. The pipe geometry are known to you. The diameter of the pipe or the lateral dimension of the pipe is 0.5 meter and length of the pipe is 10 meter. The horizontal force or the lateral force is acting at a distance of 1 meter from the ground level. Therefore, E equal to 1 meter in this case. And you need to calculate the value of R, where R is called the relative stiffness factor. For over consolidated clay, the relative stiffness factor is called R. If it is normally consolidated clay or sandy bed, then the relative stiffness factor is called T. And you know the value of R I have given you in the last video is the fourth root of EI of the pi divided by K into B. This is the equation. So if you substitute for M30 concrete, the value of modulus of elasticity of the pi is going to be 27.386 into 10 raised to 6, and the moment of inertia will be pi d4 divided by 64 divided by K into B. So K is already known to you, 15,000 kilonewton per cubic meter, and B is the lateral dimension of the pipe, that is the diameter is 0.5. You need to find out the fourth root of this. So if you calculate this and substitute all the values, you will be getting, this is going to be in meter 1.829 meter. So the value of R, relative stiffness factor, is known to you. Therefore, you can calculate E by R. E in this case, the horizontal force is acting at 1 meter. So 1 meter divided by 1.829. Therefore, E by R will be 0.547. So it is going to be 0.547. And then you use the IS code chart, from where the depth of fixity you can find it out. So use the chart given in IS 291 part 1 section 1. So if you are using the chart for E by R equal to 0.547, the value of depth of fixity upon R, on the y-axis you can get it, which is given as 1.55. Therefore, the depth of fixity of the pi ZF will be 1.55 multiplied by r. So it is going to be 1.829 meter. So depth of fixity you can calculate 1.55 into 1.829. This is equal to 2.834. So this is equal to 2.834 meter. So depth of fixity of this pipe, the pipe is going to deflect like this, and the depth of fixity is here. This is the depth of fixity where the deflection is going to be 0. So this depth of fixity ZF from the chart you are able to find it out. So having found out the depth of fixity, you can find out the reduction factor. So the reduction factor, if ZF by R is known to you, so ZF by R being 1.55, you can also find out the reduction factor. So the reduction factor N equal to 0.52. Therefore, you can calculate the mu, which is given in this problem. The value of mu, the moment is given to you 100 kilonewton meter. So mu equal to the horizontal force which is acting into E plus ZF. This is the eccentricity, this is ZF. So QH into E plus ZF into reduction factor N. So therefore QH equal to the horizontal force based on the given moment will be mu divided by E plus ZF into M. So if you substitute the value, mu is already given to you as 100 kilonewton meter divided by E is 1 meter, ZF you have calculated 2.834 meter, 834 meter, and the value of M from the chart is 0.52. So calculate QH. So QH can be easily calculated. So if you calculate 100 50.1, so QH equal to 50.158 kilonewton. Therefore, QH can be found out. So this is the answer for this problem. Suppose you are given the displacement. So if the displacement is given to you, you can use the expression already explained to you in the last video. Say the value of displacement, maximum displacement is given to you and you want to find out the magnitude. So based on the displacement also, you can use the expression and you can find out the displacement of the part. So this is how you can calculate the various quantity, and you can solve any problem based on a sport method. So thank you.